Welcome to LNP Renewable System Data. Today we are going to discuss some of the basics of the electric vehicle part 11. So if you have missed out part 1 to 10, no issue, because we had already split the session into 24 parts. So if you have any doubt, please subscribe to the channel and press the bell icon. In our channel we had created a playlist. Inside the playlist you can see all the parts that we had already discussed. So in our videos we might be using so many abbreviations, so if you have any doubt, please refer to these abbreviations for your clarity. So what are the things that we are going to discuss today in this part? How a back EMF profile of a permanent magnet synchronous motor and permanent magnet brushless DC motor looks like, and what are the different commutation methods used in permanent magnet synchronous motor and permanent brushless DC motor. How a 6-step commutation is performed in the motor, and what are the advantages and disadvantages of this brushless DC motor. Now how a brushless DC motor and a permanent magnet brushless DC motor assembly looks like, and what are the commonly used permanent magnet rotor configurations. So when we look into the back EMF profile, this brushless DC motor and the permanent magnet synchronous motor are similarly structured, but only difference is that in the brushless DC motor we have a trapezoidal back EMF shape, whereas in case of permanent magnet synchronous motor we have a sinusoidal shape. So owing to this difference in shape, this brushless DC motor are being controlled by trapezoidal commutation, whereas in case of permanent magnet synchronous motor it is being controlled by field oriented control. So when we try to get into this 6-step commutation process, okay, we are trying to energize the coil in pairs. For every 30-degree alignment we have different alignments. So for every 30 degree we are trying to energize two coils, two phases at a time. We are trying to commutate two phases at a time. See here we have a 30 degree, 90 degree, 150 degree, 250 degree, 270 degree and 330 degree. So if we look into this video, it will be pretty clear about what is happening. See here, we have a 30 degree alignment, we have a 90 degree alignment, we have a 150 degree alignment, 210 degree, 270 degree. So after every 30 degree, see here, we have two parallel alignments of we have two same phases at a time. So we have 6 different rotor alignment configuration. Okay, each is being getting apart from 60 degree. So what are the advantages of brushless DC motor? It has a high power output, okay, it has a high efficiency, it has a low profile design possibilities, okay, and it is easy to control using the trapezoidal commutation. When we get into the disadvantages, since we are using the permanent magnet field, it can cause us vigorous drag. Okay, it can be this, since we are using the permanent magnet, it can get demagnetized at a high temperature. Okay, and most importantly, since the field get weakened, often we need additional current to energize it. Okay, and it has a slight more torque ripple when compared to the permanent magnet AC motors. And when we get into the vehicles, we have 3 different categories. So we have a in-wheel hub motor assembly, and we also have the mid-drive motor assembly. For the in-wheel hub motor assembly we might be using permanent magnet brushless DC motors, whereas in case of mid-drive motor we are using the brushless DC motors. Okay, and if we get into the salient features, for this one we need air cooled one, and it is IP65 since it has a very good protection from air and the dust. Okay, and it has a very better power ranges. So when you get into the hub motor assembly, it is easy to install and replace. Mostly it is used in the 2-wheelers, it is mostly used in the 4-wheelers. And when we try to compare the voltage range of these two motors, it is 72 volt DC, it is 60 volt DC. Okay, and rated power is mostly 0.5 kilowatt. Up to 2.5 kilowatt we can use this motors, and peak power will be 5 kilowatt, whereas for the peak power of this in-wheel hub motor assembly is maximum 1.2. So maximum speed is 43 kilometer per hour we can go, whereas in case of this the maximum speed is more when compared to this vehicles, because torque is more here. So during the no load condition RPM will go up to 4000. Okay, so the maximum weight of this assembly is 8 kg. Its operating range is from 10 degree to 80 degree. Its maximum weight is 9.5 kgs. What are the commonly used industrial permanent magnet rotor configuration? So when you see here, so these are the different configuration of permanent magnets which are used for the motors. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had provided the contact details here. We are providing PLC programming training, that is programmable logic controller training for Siemens Anabiotic Delta PLCs for EEE, ECE, electronic instrumentation engineering students, along with the certification. So you can contact us. And if you had a plan to work in the GCC countries, then you can contact us. We are providing training in the building management system, building automation and control system, along with the training certifications. And if you had a plan to design, install or testing and commissioning or consulting supports for solar on-grid, off-grid and hybrid application, then you can contact us. We had provided the contact details here. And if you had a plan to establish the forms for your agriculture forms, you had a plan to implement the fences, then you can contact us. We are providing solar fencing as a kit. And if you had a plan to know the electric vehicle basics, then you can contact us. We have provided the contact details here. So we will provide you the training in online as well as in the offline, along with the certification. Thank you so much.